Hi, it's Mr. Fletcher here. So today I want to look at simplifying surds. So I'm going to go through 6 examples. So the first one, A, I want to simplify the square root of 100. So a surd means that we've got something inside a square root bracket. The square root of 100 is quite a nice one because 100 is a square number, so the square root of 100 is just 10. So that just becomes a nice straightforward answer. So if we have a look at another example then, where we want to simplify the square root of 15, what we're going to use is a technique here that's very, very similar to prime factored trees, but I guess it's going to be like a prime surd tree. So we're going to break up the 15 into 2 branches, so we need 2 numbers that multiply to 15, so it's going to be 3 and 5, but because it's the square root of 15, it's the square root of 3 and the square root of 5. So what we're saying here, like prime factor trees, is that so that's 3 is a prime number, so I'm going to circle it. 5 is a prime number, so I'm going to circle it. So what we're really saying here is that the square root of 15 is equal to the square root of 3 times the square root of 5, which is great. But if we're trying to simplify this, then actually the square root of 15 was actually simpler than the square root of 3 times the square root of 5. So actually we've tried to simplify it and we found out that it doesn't simplify. So actually it just equals the square root of 15. So let's do another one. So we'll do the square root of 28. Okay. So let's break this down. So I'm going to break that down into, let's say, 4 times 7. So that's going to be the square root of 4 times the square root of 7. Now 7 is a prime number, so I'm going to ring that. And 4, well, the square root of 4 is just a nice square number, so that's just going to be 2. So the answer to this one is going to be 2 times the square root of 7. Now because this is like algebraic notation, the multiply sign in here between the 2 and the root 7 is invisible, but it does mean 2 times the square root of 7. Okay, so let's have a look at some more examples. So if we have a look at, say, example D, where we're going to do the square root of 24. So what I want to do here is I'm going to break this up. And there's more than one way to do this. I'm going to sort of go a little bit around the long way here. So I'm going to say I'm going to break that up into a 2 and a 12. And the 2 is prime, so that stops that branch. 12 is not prime, so we need to keep going. So that's going to be 2 times 6. And the 2 is prime and the 6 is not, so let's smash that up a bit more. That's going to be 2 and 3, and they're both prime, so we're done with our prime surd tree. So it equals the square root of 2 times the square root of 2 times the square root of 2 times the square root of 3. Now what you need to kind of remember, I guess, is that the square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 we know is just 2. So when we multiply 2 square root brackets together that have the same number in them, you just get the number back that's inside the bracket. So that's just a 2. And then we've got that and we've got that all multiplied together. I'll give myself a little bit more space down there now. And so we're kind of almost done, and we found out that we've got root 2 times root 3 at the end there. That's not particularly simple, so maybe we need to smash those back together. So 2 times 3 is root 6. That's going to equal 2 times the square root of 6, because we just multiplied those back together. And root 6 is simpler than root 2, root 3. And let's have a look at another one then. So E, the square root of 75. So I'm going to smash that up into 5, and it's going to be 15, isn't it? So square root of 5, square root of 15, and 5 is prime, 15 isn't. So I'm going to break that up into root 5, root 3. So 3 times 5 is 15, that's good. And both of those prime. So our tree's finished. So what we've got is root 3 times root 5 times root 5. Unlike before, the root 5 times root 5 is just going to give us just a number 5. So it's root 3 times 5. But the rule for surds is that the whole numbers would kind of come before the root bit, so that's just a convention. So it's just going to be the same as 5 root 3. Okay. Last one then. So let's say f write square root of 32 as a root 2. Okay, this is a more sort of exam style question now. So let's write the root 32 then. Let's break that up, and we can break that up into many ways we can do this, but let's say it's going to be 4 times 8 is 32, isn't it? So 4 times 8. Okay, so square root of 4, square root of 8. Well, we know what the square root of 4 is, because that's just 2. So now we need to so that's parked. Now we just smash the 8 up into, well, that's going to be 4 again, isn't it? Square root of 4 times the square root of 2. Now 2 is prime, and 4, we know the square root of 4 is just 2. So that is going to equal 2 times 2 times the square root of 2. Now 2 times 2 is 4, so it's going to be 4 root 2. So if you wanted to think about it in terms of what was a, well, a is just the number in front of the square root. If you think back to kind of what the question said, if the question said what is a, you would write a is equal to 4. But I guess for the question we were looking at, 4 root 2 would be good enough. Alright, hopefully that explains enough for you to do some simplifying surds.